Me? Oh, I think now everybody can hear me. Good afternoon, everybody. This is Frank. My name is Jorrit. We're going to tell you, we're going to give you a small presentation, a tutorial on how to create large-scale distributed networks for the safe healthcare information exchange. We are at FHIR DevDays. This FHIR is one of the key components that we will use to create these distributed networks. And the other part is NUTS. And I guess that most of you know what FHIR is, and that most of you don't know what NUTS is. So we will give a short introduction on that. These are the learning objectives for the upcoming 45 minutes. An explanation on NUTS, of course. The second part will be a presentation by Frank on the NUTS plugin for file and server, which can make it really easy for you to update your FHIR server with a NUTS plugin, so that you can easily, scalably secure your FHIR APIs. And the last part is a short explanation on the differences and the relationship between Smart on FHIR on the one hand and NUTS on the other hand. So let's start with the first part. What is NUTS? And I want to talk you guys through all these topics. So I hope you can keep up. In the basis, NUTS is an open source community that creates a trust layer that you can use for secure data sharing on the internet. The internet by itself is not really trustworthy. It's pretty anonymous. So you need something on top of the internet to be able to make it safe. And we always like to use the metaphor of a trust layer. I also have a little bit longer explanation, and it's a video. And now it starts to become exciting because we have to start in the video. And I have to talk through and do things like this. It's a really cool video. You have to see it. It's in English. That's good. Has lots of bright colors.
I just found out that we need to share it, so give me a second.
Okay. Is nu niet hier, hè?
Systems of GPs, specialists, nurses, and other healthcare workers. You would expect this data to be shared between the different systems in a safe manner.
Stop share.
Oh, you expanded the desktop, maybe. Not a mirror.
Healthcare data.
Ja, dit is het gewoon.
Moet je die niet naar de andere venster slopen? The next presentation we will give, we will download the YouTube video and embed it in the presentation. Oh, this looks good. Maybe start from the start.
Healthcare data is spread across the IT systems of GPs, specialists, nurses, and other healthcare workers. You would expect this data to be shared between the different systems in a safe manner, and that patients would know who viewed their data. But currently, that is not yet the case. That is why we, suppliers of healthcare software, have joined forces in the NUTS initiative to develop an open source protocol that regulates access to healthcare data. The protocol is like a smart key store that is linked to the healthcare professional's software, and it works like this. A physician refers a patient to a specialist at the hospital and provides access to the blood test results in the patient's file, Her key store creates a unique key that clarifies which specialist is allowed to view the file, what may be viewed, and where the file can be found. The key is then stored in the specialist's key store. Only when the key and the identity of the specialist have been checked can he access the patient's data. The patient can view when the key was used and by whom. If the patient or the physician withdraws the authorization for the key to be used, that key can no longer be used to view any data. Safety guaranteed. This is just one of the many ways in which NUTS promotes collaboration between healthcare workers, because every system secured via NUTS allows healthcare data to be shared in an easier and safer manner. NUTS, secure data sharing.
Okay, I hope it gives you a little bit of more idea of what NUTS is. Did it help? Okay. I think the most important thing that you have to remember after seeing this video is the little keys, the key locker boxes that are exchanged, that are used to secure the access to data, FHIR data for today. And in the next upcoming slides, I want to give you some more information on how it works under the hood.
Nee, dat is hem niet. Ik moest hem extern.
If the presentation pops up again. Yes, that's good. Then I'm here. Okay, so I'm going to explain NUTS to you via a simple example. Most of you guys have really cool FHIR APIs. And if you have a cool API, you want as many people to use it as possible, but it has to be safe. So if you want as many people as possible to use it, you want to publish it on the internet. This is like an Inception thing. I want to go in there. Okay. You publish it on the internet, but then there's some challenges. Because how will you decide upon who will have access to your cool FHIR API and who doesn't have access? Because on the big bad internet, there are trustworthy people and not so trustworthy people and organizations. One idea to secure your FHIR API is to create a list of clients. I put it in here somewhere. Yeah, okay, cool technology. List of clients. You could create a list of clients, and if somebody sends a request to your cool FHIR API, you can check is the person or the client, is it on the client list? I give access, and if it's not on the client list, I don't give access. It's a pretty cool idea, but there are some problems with it. If we look at the Netherlands, there's 100,000 healthcare organizations. So you need a pretty long client list if you want to use this strategy to secure your FHIR API. Not to mention that you might also want to give access based not only on the organization that sends a request, but the person behind the keyboard. And then that number of clients will exponentially grow as well. So this is not really a scalable strategy. Can we do better? Now, some people in the US, for example, have thought of a pretty good idea. It's called UDAP. And UDAP, basically, it says you can dynamically create clients. So you don't have to create your client list yourself, but people that do a request can send a certificate accompanying the request. You can check the request. If you like the attributes in the request, you can dynamically add clients and then give access to your FHIR API. But also with this strategy, there are some problems. One of the main problems is that certificates are not that flexible. Certificates, The attributes that are on a certificate are not really easy to change or adopt. And in healthcare, there are like hundreds of use cases we want to support. And we don't know yet what attributes we will need in the future. For now, you could think of, we want an attribute that says what is the name and the role of the healthcare provider. But maybe in the future, we want to add different attributes. Certificates do not support that flexibility, which makes it less scalable. Another problem is that UDAP is a custom extension on OAuth 2. Like FHIR, I think one of the big reasons why FHIR is that popular is that it's really close to normal internet standards that normal internet developers use every day. So you want to be resilient on using custom extensions. Another problem is that UDAP uses authentication on a system level. So it's not yet usable to support authentication on a person level. Because you can think, if you want to access a FHIR API using your phone, it's pretty hard to include a certificate. So the conclusion, it is scalable, but not very scalable. And I think we could do better. And this is what Nuts does in a nutshell. It looks a bit like UDAP, with the difference that we don't send a certificate within our request, but we can accompany our request by all types of attributes. And it doesn't really matter which attributes, we just have to agree upon them and we can use them. So you can use attributes of the person, of the vendor, attributes of consent, attributes of a legal entity. And Nuts makes it possible to check the validity of these attributes, integrity and authenticity. And the FHIR API can then provide access based on these the values of these attributes. To do this, we need a couple of standards, because you have to be absolutely sure that if you receive an attribute, hey, this is Jorrit Spee, he is a gynecologist, he works at this and that hospital, his shoe size is US 10. You need to be absolutely sure that these values are correct. So you need to work with digital signatures. And you need the digital, so to check these digital signatures, you need a public key infrastructure. And the good thing is, a lot of smart people have thought of a couple of standards to do this. You can see them over there. 2 standards by W3C. One is called decentralized identifiers. And one is called verifiable credentials. And the third standard, it's called OpenID for verifiable credentials. This is a very flexible solution because we could actually use all the attributes we need. We just have to agree upon who is the issuer of this attribute and what do we need to trust it. The cool thing about these standards is also that there is big support, at least in Europe, by upcoming European regulation about European identity and authentication services, EIDAS it's called. So we think this is a really scalable solution. But then again, how does it work? We want to go one step further in the explanation. And to explain to you how it works, I want to introduce a new model. It's called Trust over IP. Somebody heard of it? One person has heard it. Very good. It's a really cool model. If you're into trust, I can imagine at a FHIR conference, you guys all like data, which is cool. But trust is also very cool. And trust over IP, the name says it. It's a model to be able to create trust over the internet. and just the internet, nothing else, which is pretty cool because normally we realize trust by signing contracts, big bags of paper, audit trails, blah, blah, blah. And that all is not scalable because if it takes you like 6 months to write all the contracts and stuff to join this network, then you can imagine how long it takes for 100,000 healthcare providers in the Netherlands. So we need something to technically create trust. Trust over IP is the network. It consists of 4 layers and 2 columns. This is just one of the 2 columns. The other column you can look up at the website. And I want to talk you through these 4 layers. Now we'll start at the bottom. The first layer, it's called public utilities. And that is the layer where the decentralized identifiers standard comes in. Basically, it's a standard. Yes, very good. It's a standard for creating a technical identifier that is verifiable. So you could say that it's a technical identifier bound to a verification method like a public-private key pair. At the bottom, you can see what it looks like. A DID identifier, it always starts with DID. And then example over here, it's a method identifier. At nuts, it's always nuts. And then there's this string. And the DID identifier is always bound to a DID document. That's what makes it really handy. So people that have the identifier on the left can always resolve the DID document that is on the right. And in the DID document, organizations can, you see it maybe, can publish all kinds of public things, like this is a public key you can verify my signatures with, or this is the URL of my cool FHIR API, stuff like that that is publicly available. So then we have, this is actually our decentralized public key infrastructure. DIDs by themselves do not really have a meaning. To provide meaning and attributes to it, we need the verifiable credential standards, that are on layer 3, which I will come through in a minute. Layer 2 of the trust over IP model is about the protocols that are used between agents and wallets. So the model actually, it works like this. We have all kinds of entities in a network. They can be organizations, persons, systems, applications, and they all have attributes. And these attributes are signed by trusted third parties, and the attributes are stored in little wallets. We call them wallets. And you need a protocol for these wallets to talk to each other. Now, this protocol, it's called OpenID for verifiable credentials. This is the URL. I will not go into much detail about it because it's not yet included in the implementation that Frank will show you in a minute. Layer 3 is about the verifiable credentials, which are the attributes themselves, like my shoe size or my name or my age or my authorizations. One of the important things about verifiable credentials, I cannot really pinpoint it now, is that there's 3 roles involved. You can see them. At the left, there's an issuer. So that's the issuer of an attribute. So if it's about my shoe size, the issuer could be the Dutch Association of Shoemakers. In the middle, there's the holder. That's me with my wallet. And in that wallet, there can be an attribute with my shoe size that is signed by the Dutch Shoemaker Association. And on the right, there's the verifier. That could be a shoe store. If I go to a shoe store and the guy wants to be absolutely sure that my shoe size is US 10, I can provide them with my wallet and the attribute that is signed by the Dutch shoemaker authority. And then he absolutely is sure that my shoe size is US 10. A verifiable credential consists of 3 parts. There's some metadata at the top. The main course is the yellow part. It's called claims. That's where the attributes themselves live. And there are some proofs at the bottom, which are just digital signatures. And as you can see in the big yellow box, these are just some examples of claims that you can put in there. So I already talked about role, employee relation, where do you work, consent stuff, authorization stuff. Actually, your imagination is the only boundary. In the use case that Frank will show in a couple of minutes, there's one verifiable credential type that is used very thoroughly. It's called the NUTS authorization credential. And basically, it's an authorization record that states this entity can access that resource from that patient at that other entity. And it is also always scoped to a specific use case. In the use case that Frank shows, it's scoped to a referral. It looks like this. I highlighted the most interesting stuff. So the data holder is in there. This is the DID of the data holder. Then there's the DID of the data user, the one that wants to access your cool FHIR API. And then there's a list of resources. In this example, there's only one resource that is a document reference. You can put in some operations there. You could use the same operations as in Smart on FHIR scopes. So it's CRUD plus search. But you could also make up your own if you want. And the other field, user context, it's pretty nice because there it's a Boolean that states if it's necessary for the person behind the keyboard to authenticate her or himself to be able to access the data. You can imagine some data, it's possible to access it via a system. You don't need to know who the exact person is. And some data, you really only want to share it if you know who the person is behind the keyboard. Purpose of use is the service, and subject, it's a social security number of the patient involved with a OID in front of it. Okay, now that we had this talk, if you sum it all up, it's basically this little stack of standards that we use to scalably secure your cool FHIR API. So starting from the bottom, TLS, it's like a hygiene factor. I think it's pretty common to use it. DIDs on top. On top of that, OpenID for VC for your protocol to exchange data between your wallets. Verifiable credentials on top. Then there's your FHIR API, and via that FHIR API, you're going to exchange FHIR data. And this stack, maybe to you, it looks a bit futuristic, or new, or exciting, or spannend. But the cool thing is, it's already being used on a really large scale. At least in the Netherlands, it's being implemented on a nearly national level in birth care, on a big level in long-term care. We use it to create actual medication overviews, regional actual medication overviews. And you're going to see a use case of a referral in a minute. And a couple of weeks ago, we did a hackathon with the MDT application from Parsec, which also uses this stack. It's an infrastructure independent stack, which is cool. So everybody can implement it. I already told you it aligns with European regulations and with this cool trust over IP framework. So I would kindly invite you, if somebody asks you about trust and how you are planning to scalably secure your cool FHIR API, to suggest why should we use this stack? Because Jorrit told me it's a good idea. It's always a good argument. Okay, how does it looks if you want like pictures? This is what it looks like if you like pictures. On the left, there's a data holder. On the right, there's a data user. They both have a nuts node. It's the agent and the wallet I told you about earlier. They exchange some stuff like authorization records and service information. For instance, what is the URL of my FHIR API? And the actual data requests and data responses are done directly via the FHIR server and FHIR client. So nuts is never in between things, which is cool as well. A lot of infrastructures try to be the man in the middle. And man in the middle, it's generally a bad idea because it introduces a lot of security and privacy concerns. So it's cool that Nuts makes it possible for servers and clients to interact directly with each other using tokens that Nuts has created for you. One more thing before we can go to Frank. The use case that Frank will tell you about uses a mechanism that in the Netherlands it's pretty common, but I think in other countries not that common. It's called notified pool. And notified pool, why is it a good idea? Now, we have some concerns with push. Push has very limited authentication possibilities, and unsolicited pools, yeah, why should you pull? When should you pull? It's not that easy. And a notified pool breaks those disadvantages. So how does it work? In a referral, there's a sender and a receiver. Sender sends a notification that includes some references, and the receiver can act upon that notification by pulling the data. I think we're now ready for Frank.
Yes,
Thank you.
So about 2 months ago, I participated in a connected fund. The goal there was to have a bunch of vendors together and that they would exchange information, FHIR of course, using Nuts as a trust layer. It was for the use case of a BGZ referral. Maybe some of you also were in my talk yesterday, which was about FHIR module 3. That's actually a very nice example of what a referral looks like. You're in one hospital, you're being referred to another, they treat you there, and then they send back the outcome of whatever treatment they applied. The code that I wrote there is proof of concept level code. So it's ugly, it's not secure, etc., etc. Still, I made a GitHub repo out of it because it took a couple of days to set up a Nuts node. It takes time to configure it, even though there were some people from Nuts there to assist us. Then it takes time to understand what the flow looks like. And then, of course, you also need to implement it. So in this GitHub repository is the start of something like a C# Nuts client. But the most important thing is that you can see which steps you need to take. And what I'll do is I'll talk you quickly through those steps so that if you're interested, you can clone this repository, you can get it to work locally, and then you can either look at the slides or look at the recording and have a little bit of extra information. So there's a repository, there are instructions in there in the README, quite extensive. Then there is a Docker Compose file in there that will spin up 2 Nuts nodes and 2 FHIR servers, because what we're mimicking is one vendor and another vendor. These vendors each have one organization. These organizations are hospitals, and then we're doing a one-way referral. There's a Postman collection in there. Most of it is for setting up your Nuts node, and some of it is for setting up your FHIR server. And then there is a File Server plugin in there, and that contains 2 bits of functionality. For those of you who don't know File Server, it's a FHIR server. It's extensible. You can write a plugin in C# code, and then somewhere in the request pipeline, you can insert this logic to modify the behavior. That's what this plugin does. It has a custom operation in there, which is called $refer. You say, I want to refer a patient to this hospital, and then you provide the name. And the notification task handler is a plugin that actually intercepts any task that gets put or posted to the FHIR server and then does something. Now, this is what the flow looks like. So you have a sender FHIR server and node on the left. You have a receiver on the right. It's not server client. It's really system to system. And then the first thing that you do is you trigger this $refer operation and you provide the name of the hospital you want to send it to. Then the FHIR server will interact with the NUTS node and it will get the DID, the decentralized identifier document that Jorrit just described based on the name. Of course, it's a happy flow. We search for a name and we get one hit back. The second step is that you create a workflow task. A task is just a regular FHIR resource, but in this case, it's tailored specifically to the use case for a referral. So what's in this workflow task? Basically, all of the information that you want to refer to the other hospital. You store that in your FHIR server, and then the next thing the FHIR server does, it asks the NUTS node, or actually it instructs the NUTS node to create a NUTS authorization credential. So that's a verifiable credential in which you state which rights you're giving to this other party. So you name the party, you name the FHIR resource, you make it all explicit. You write it to your local NUTS node, and these NUTS nodes have the nice feature of synchronizing amongst themselves. So whatever authorization credential you put in there, it's going to end up on the receiver end as well. Then you obtain the notification endpoint because we're doing a notified pool. So we need to know where we need to send this notification to. That's also being requested from the NUTS node because the notification endpoint is listed in the DID document. Then you obtain an access token. That's one of the other nice features of a NUTS node. It can also function as an authorization server. So you ask it for an access token. And then you create this notification task. And of course, the last step is sending over the notification task with the access token. Now, what's the notification task? It's again a regular FHIR task. And the only thing it contains is basically a ping. I have some information for you. And I'm not telling you what information it is. I'm just telling you where you can find it, what the use case is. And if you're interested, you can come and get it. So we're not pushing any information up front because we don't know if the hospital on the receiving end is interested or when they will be interested. We're just sending this minimal footprint notification. So that's the first flow. It's here all together as a sort of a cheat sheet. I'm running out of time, so I'll skip over this little bit. What I do want to show you is the contents of a NUTS authorization credential, and then specifically these two bits here. So what you're making explicit here is there is a task resource and you provide the ID of the task resource. And the second thing is that you're making explicit what kind of operations the receiver, wow, 1 minute, the receiver is allowed to perform. So it can read and it can update. Now, for those of you that know Smart on FHIR, in version 2, this can be expressed very nicely. You list task as a resource type, and then you say you can read it or you can update it. And why do you need to update the workflow task? Because if the receiver says, okay, I'm going to process this workflow task, it should inform the sender on that as well. Now I'm going to start talking really quickly. This is the other way. So you just got the notification and now the receiver is going to process that. So it's going to introspect the token to make sure that it's valid. Then in this notification task is a little bit of information. What's the DID of the sender? What's the ID of the workflow task, as we just saw? And there's also the DID of the NUTS authorization credential in there. It's going to obtain the FHIR endpoint. Where can I get this information? It's going to get a NUTS authorization credential indicating what it can do. And then using that, it's going to obtain an access token. And then the last step is to actually retrieve this workflow task. And the workflow task contains a long list of inputs stating what information is ready for you. And then the FHIR server will iterate through this input, executes the queries in there, retrieves the information, and then can store the information in the FHIR server. So that's the processing of the search bundles. Again, a bit of a cheat sheet. And this is the last thing I want to show, because then Fop is going to interrupt me. This is one of the inputs in there. So what you see here is just a FHIR query. There's an observation, there's a last N operation in there, and they have made explicit what kind of category you're allowed to retrieve. So this is basically telling you you can get the last 5 observations for this specific category. That also fits sort of nicely into Smart on FHIR. So we can express the observation, we can say that you can read the information, and we can specify the category. The only thing we can't express in Smart on FHIR at this point in time is the last N operation. So this is the proof of concept. The next step is that we're actually going to implement this at a customer side, learn what other issues we're going to run into when we actually start implementing it. We have a few questions already. Is the NUTS node going to be handing out Smart on FHIR scopes, or is the FHIR server going to be able to interpret the NUTS scopes? Is it okay that we use multiple Smart on FHIR scopes as part of the token? Is that expressive enough to cover all of the data needs? And the only thing we need to think about is that Smart on FHIR scopes do not support operations like last N. So what are the implications of that? You want to wrap it up?
Yeah, you can read here.
And I think
It's a
we're
good
out of time
checklist.
anyway.
If there's some unclarities in there, that's a little bridge, I think, to the question time.
Well, thank you very much. So I didn't see any questions on WOVA, but maybe there are some in the room.
Yeah, thanks for the presentation. It's pretty clear. I do have some doubts when I see the stack for the authentication, to be honest, because it started off with saying that the certificates are not really flexible, but certificates do support extensions. Most of them quite well known, such as key users or subject alternative names. But it's certainly possible to define and use your own certificate extensions. And when you use that, it would eliminate the need for an external authentication provider like OpenID, because the client can just send its certificate and use that for signature. It would also probably, it would eliminate the need for the notified pool, because it's also usable to authorize with push, because the authorization happens within the TLS handshake. Has that been considered?
Yes, it has. I think one of you only see a referral right now, and the referral is actually the most easy use case, because the sender knows who is the receiver, or the data holder knows who is the data user. If you look, for instance, at birth care, that's not always the case. It's more a network setting where pools can be done, and it's not always easy to know beforehand as a data holder who will be sending data requests. And I think in those situations, it's harder to rely solely on certificates. But I'm not a certificate expert, so I believe you that it could be it could be a solution direction. I don't know if it's in what extent it has been explored. What I do know is that doing it this way in 2 years' time in the Netherlands, we have been able to tackle a big chunk of use cases, which strengthens our feelings that this might be a very good strategy to do it. One thing about certificates, because in the Netherlands we have actually a lot of experience with certificates. A lot of healthcare professionals in the Netherlands use a little smart card. It's called the Uzipas, which is actually publicly, there's a certificate involved in there. And it works pretty okay, except for that it's hard for people to use it if they are on the road with their iPads or tablets. How can they use the smart card? We could, of course, virtualize the smart card. That is a strategy that is, I think, also adopted for NHS in the UK. But this strategy for nuts actually goes one step further and says, okay, we just decouple the certificate, the signature part from the attribute part to make it more flexible.
Okay, thank you very much. Any other questions?
Sorry for the unclear answer, but it was a difficult question.
I know that the IHE has some profiles for, I think, enterprise user authorization and internet user authorization. I'm not exactly sure about the details of this one, but how does this fit in, or is there any overlap?
Yeah, we've looked into it, because also in the Netherlands there are some pretty big IHE XDS implementations. There are two user authentication profiles. One's called XUA, I think, and one is called IUA. X is for cross organization and I is for internet user authentication. The IUA protocol really fits nicely with NUTS, can fit nicely with how NUTS sees things. The problem that we face in the Netherlands is that most IUA implementations that are in place do not support this profile. They only support the XUA profile, which is not, which has a bigger gap with the NUTS way of authentication.
We still have time for one small question. It seems no questions. Then I would like to thank both Frank and Jorrit for presenting today. And thank you all for coming, and have a nice afternoon.